All right, let's talk about dynamic programming. If you've ever heard that term and felt your brain start to glaze over, you're not alone. But today, we're going to cut right through all that complexity and settle a classic debate: memoization versus tabulation.
And this really gets to the heart of it, right? If both of these techniques get you to the exact same correct answer every time, well, why should you care? Why would you ever pick one over the other? That's the big question we're going to answer today.
But before we can really compare these two, we have to get on the same page about what dynamic programming, or DP, even is. What's the fundamental idea they both share?
At its core, DP is all about being smart, and frankly, a little lazy, in a good way. It's a strategy for solving massive problems by chopping them up into smaller, more manageable pieces. The real magic, though, is in those key words: finding overlapping subproblems and storing their solutions. In other words, you solve something once and only once, so you never waste time redoing the same work.
You know, for DP to even be on the table, a problem needs to have these two key ingredients. First, those overlapping subproblems we just talked about. This just means you find yourself needing to solve the exact same smaller problem again and again. And second, something called optimal substructure. It sounds complicated, but all it means is that the best solution to the big problem is made up of the best solutions to its little parts. Simple as that.
Okay, so with that foundation in place, let's finally introduce our two contenders. Think of them as two totally different paths that, somehow, always lead to the same destination: the single best answer.
First up, we've got memoization. This is the top-down strategy. You start with the big, final question and work your way backwards, using recursion to solve smaller problems, but only when you absolutely need to. On the flip side, we have tabulation, the bottom-up approach. It does the complete opposite. It starts with the tiniest, simplest possible problems, the base cases, and builds its way up, step by step, until it's constructed the final answer.
Top-down, bottom-up. I know, it can sound a little abstract. So let's make this crystal clear with a really simple analogy.
This hits the nail on the head. Picture a big roadmap where every city is a sub-problem you need to solve. Memoization is like firing up your GPS. You punch in your final destination, and it figures out the path by working backward from there. Tabulation, though, is more like being a road builder. You start at City 0, and you methodically pave every single road, building out the entire network until you eventually reach the destination.
So let's put on our explorer hat for a second. With memoization, you start at the big destination city. To get there, your GPS says, wait, you first have to figure out the path to this smaller city. So you go there. Once you've solved a city's path, you leave a little sticker on it with the answer. Now, if any other route tries to send you back to a city that already has a sticker, you don't do all the work again. You just read the sticker and move on. You only explore what you absolutely have to.
Now let's switch hats and be the road builder. With tabulation, you actually ignore the final destination at first. You go to the smallest, easiest cities, the base cases, and solve them. Then you move on to the next set of cities, using the roads you just paved to solve them. You just keep building, methodically, solving every single subproblem in a predetermined order. By the time your grid reaches the destination city, the answer is just sitting there, waiting for you.
All right, analogies are great, but let's get down to brass tacks. How do these two strategies actually perform when the rubber meets the road? Let's look at a couple of classic coding problems to see them in action.
We're going to start with the hello world of dynamic programming, the Fibonacci sequence. You know the one. To find any number, you just add the 2 before it. It's a perfect test case because you end up recalculating the same values over and over and over again.
Now this is where it gets really interesting. When it comes to time, they're both super efficient, what we call O of n. But look at the memory, the space they use. Memoization, with all its recursive calls, stacks them up and uses O of n space. But tabulation? Tabulation could be optimized. See, to get the next Fibonacci number, you only ever need the last 2. So you don't need to store the whole list. You can get it down to O of 1, or constant space. That means it uses the same teeny tiny amount of memory whether you're calculating the 10th number or the 10 millionth. That is a huge win.
Okay, time to level up. Let's look at a trickier puzzle, the coin change problem. Given a bunch of coins, say pennies, nickels, and dimes, and a target amount, what's the absolute minimum number of coins you need to make that amount? This is where the trade-offs get much more nuanced.
This table really pulls it all into focus, doesn't it? For tougher problems like coin change or finding the longest common subsequence, the worst-case time and space often look identical. But the devil is in the details. Look at those little optimization notes.
Just like with Fibonacci, that bottom-up, systematic approach of tabulation often lets you pull off some really clever space-saving tricks. You can use techniques where you only keep track of the last row or two of your table, which can slash your memory usage. It's kind of tabulation superpower. So, after all that, we're back to our original question. We've seen how they work, we've seen how they perform, so how do you actually decide which one to use?
First things first, let's bust a couple of common myths. It's not as simple as one is faster or one uses less memory. Remember our Explorer? Memoization can actually be faster if your roadmap has a ton of cities you never even need to visit. And while our road builder is great at saving space, sometimes it wastes time and memory paving roads to cities that are totally irrelevant to the final answer.
So here it is, the final cheat sheet. You should reach for Memoization, our Explorer, when the problem has a sparse state space, meaning you'll probably skip a lot of subproblems. Or, frankly, when the top-down recursive logic just makes more sense in your head. And you should choose Tabulation, our builder, when you know you're going to need to solve almost every subproblem anyway, when you're worried about hitting recursive depth limits, or, and this is a big one, when you spot one of those amazing space optimization opportunities.
All right, we've covered the core idea, the analogy, and the real-world trade-offs. Let's wrap this up and lock in the most important takeaways.
So what's the bottom line? First, always make sure your problem actually is a DP problem. Look for those overlapping subproblems. After that, it's about choosing the right tool for the journey. Is it a sprawling map where you only need one specific path? The Memoization Explorer is probably your best bet. Is it a grid that needs to be filled out methodically? The Tabulation Builder is going to be your workhorse. It's not about which one is better, it's a strategic choice you make every time.
And with that, I'm going to leave you with a little challenge to chew on. The house robber problem. You're a thief, you've got a street of houses, and you can't rob two right next to each other. How do you maximize your loot? Think about its structure. Would you send in the Explorer or call up the road builder? And more importantly, why? Thanks for digging into this with me.